Let's solve a basic system of three equations. Now, why is it basic? Notice that two of the equations don't actually have all the variables. We're going to use that to our advantage, but you have to be wise about the way you eliminate variables. So what we do is we first shave off one of the variables. So notice I identify, this equation has no y's, it has no x's in it. So what I'm going to do is I'm going to take the top two equations and I'm going to make sure that I can get rid of x. How will I do that? I'll multiply the top equation by -2. So that's negative 4x plus, now I'm going to leave a gap because I don't have any y's in this equation, plus 0 y's minus 6z. Make sure to multiply the entire equation, -16. Then here, what I have is I'll just take the same equation, 4x minus y minus z equals 7. I can combine those two equations, and these cancel. I get -y negative 7z equals, what is that, -9. Now I have an equation with y and z. I shaved off the x there. Here, I can just take that equation because that equation already doesn't have the x in it. I'll take that equation, put it right here, and what I'm going to do here is I'm going to identify another set of another multiplication that I can do so that I can solve this system of two equations to shave off the y. So we have to shave off another variable here. Let's shave off the y by multiplying the top equation by 4. We get, let's see, -4y negative 28z equals -36. This equation here, we have 4y minus 5z equals 9. So combining the two equations, the y gets shaved off. We get -33z equals -27. So that makes z equal to -27 over -33. The negatives cancel, but notice there's a 3 in common between these two terms. So we simplify to z equals 9/11. Now that we've got that, we can send it back over to figure out what y should be. So z is 9/11. 4y minus 5 times 9/11 is supposed to equal 9. So let's gather like terms. I'm going to gather the constants over here. So 4y, let's see, and I suppose this is -45/11 on this side. How many 11ths would that be? So 9/11 is 99. 9 is 99/11. And then I'm going to be adding to that, going to be adding to that 45/11. What does that come out to when I put it together? 4y equals 144/11. Well, 144, I suppose, when we divide both sides by 4, that reduces to 36. So I have y equals 36/11. Okay, so I have the z value, I have the x value. Time to come back over here and choose the easiest equation to come up with an x value. Let's choose the top one. It's got to include x, and I'd rather not deal with all the variables at the same time. So let's see what we have here. We have 2x plus 3 times my z value here. So 3 times my z value is 27/11 equals 8. Now notice here we combined the constants and we got a common denominator. That's a perfectly valid method just for variety. Here, we're going to clear the denominator. So let's see what would happen if I multiplied this entire equation by 11. This multiplied by 11 would be 22x. This multiplied by 11 would just be 27. This multiplied by 11 would be 88. There are pluses to this method, and there are also some real pluses to clearing the denominator in this kind of problem. Now what I'm going to do is I'm going to subtract 27. So now I'm gathering like terms. So I get 22x equals 61. X equals 61 over 22. Those are my x, y, and z, or I could write them as an ordered triple. 61 22nds, 36 11ths, 9 11ths.